Welcome back, Chemistry 30. So we talked about the first two rules with oxidation number, assigning them. Let's look at the rest of them. 3, for nonmetals, usually have negative oxidation numbers, although they can be positive sometimes. The oxidation number for oxygen is usually -2, and molecular in both ionic and molecular compounds. The major exception is in the compounds called peroxides, which contain O2, 2 negative ion, giving each one a -1, and we'll see examples of that. The oxidation number of hydrogen, of course, it's a group 1 element, so it's +1. If we're talking about the hydride ion, so NaH, the oxidation number of sodium is +1. The oxidation number of hydrogen is actually -1 when it's behaving like a non-metal. The oxidation number of fluorine is -1 in all compounds. The other halogens, the group 7s, they tend to have a charge of 1 negative, right? So their oxidation number is -1. When combined with oxygen as oxyanions, however, it could be different. But for the most part, we're going to see them how they usually are when they are non-metals. So again, to recap, so elemental form, which by itself, 0. Monatomic ion, equal to the charge. Group 1s, groups 2s, group 3s. Non-metals, excuse me, whether they're ionic or covalent, they have a charge equivalent to what they have an oxidation number equivalent to the charge that they would be in ion form. And lastly, on the next page, the sum of the oxidation numbers in a neutral compound is 0. And if it's an ion we're talking about, it's a polyatomic ion, it's equal to the ion itself. So for example, in the hydronium, H3+, the oxidation number of each hydrogen is +1. The oxygen is -2, so we have 3 of those +1s. And notice overall we get a +1, and that's identical to the charge it is. This rule is useful in obtaining the oxidation numbers in one atom in a compound or ion if you know the oxidation numbers of the other ones. The following example illustrates this. So let's take a look. So over here we look at what are the oxidation numbers of sulfur in each of these. So if we take a look at H2S, okay, how I like to do it is write down the individual oxidation numbers on top. Individual. And then I like to refer to it as the sum. So over here, each hydrogen, and if we look back at the rule over here, we're told hydrogen has an oxidation number of +1 unless it's a hydride. So +1. Now we have 2 hydrogens here, right? So that's going to be a total of +2. Okay? And I know that this must add up to be 0 because there's no charge up here. So I know that this is going to have to be a -2 total on the bottom. So +2 and a -2 is going to give me 0. Now since I only have 1 sulfur, and recall sulfur is a group 6, the sulfide, so its oxidation number is equal to the same as its charge if it is an anion, so -2. That's it. That's all. So individually, each hydrogen is +1, each sulfur is -2. Combine what you actually have here. I have 2 of these. +2 minus 2 gives me 0. B, if I look at S8, if I go for S8, it is equivalent to this scenario over here for an elemental form. So we just have sulfurs there. I have 8 of them. But whether I have 1 or 8, it has to equal the charge that it is. There is no charge up here, so it is simply 0 and 0. So each sulfur is going to be 0, whereas each sulfur here was -2. Over here in the next one, SCl2. Now chlorine is a group 7. Group 7s have a charge of one negative because they need to gain 1 more electron. So its oxidation number is -1. Now I have 2 of them here, right? So if I have 2 of them, that's going to be -2. And of course, there's no charge up here, so it must be neutral overall. And that means that the total number here must be +2, because +2 and -2 equals 0. I only have one sulfur here, so that one sulfur must be +2 to give me the oxidation number that I require so that it's 0 overall. Sodium sulfite. So oxygen, we're told that oxygen, it's a group 6 like sulfur, so it's going to be -2. So we're told here, go to oxygen because it's always -2 unless it's a peroxide. -2, but I have 6 of them, so that's I have 3 of them. 2 times 3, -6. Sodium, I know, it's a group 1. And looking back at the rules here, group 1s are always +1. But we have 2 of them, so it's +2. Okay, now you have to kind of work it a bit here. What number needs to go here such that this is a true statement? 2 plus what number gives, and -6 gives us 0? Well, we're going to have to add 4 here because 2 plus 4 is 6. 6 minus 6 is 0. So my total sulfurs that I have need to have an oxidation number of 4. Since I only have one sulfur, it's that one sulfur that contributes the +4. And lastly over here, E, the sulfate ion. Now I know when my totals here need to be adding up to -2, because you remember, if I'm talking about a polyatomic ion, it must add up to give the total of the charge, which I believe is, over here, on the rule number 4. So oxygen is always -2. 2 times 4 is -8. Now to make this a true statement here, the total over here would have to be +6. And since I only have one of those atoms contributing to the +6, that one atom must be +6. So there you have it. That is how we do that. If I look at oxidation reduction reactions, we determine whether a given chemical reaction is an oxidation reduction reaction by keeping track of the oxidation states of the elements involved. So now that we know how to assign oxidation numbers, we can go with that and determine what happens next. Now, if you wanted to right now, ladies and gentlemen, you could go to this assignment. Like you wouldn't hurt to do that. Go to this assignment here that you find attached here. You should be able to do the front page, which include 8 multiple choice questions. And on the flip side, over here, I'm going to cover it because this is actually the key. Take a look here. For each redox reaction below, determine the oxidation number of each compound present. Write your answer above each element. So if you look at this, maybe we'll just run through the first one here, just so you can see how you do it. Let me get a piece of paper. Here we go. So if you look over here at the first one, cadmium, it's a monatomic element. It's by itself, so it's just simply 0, and it adds up to be 0. Remember, I keep the track of the sum on the bottom and on top each individual. Oxygen here is -2, so it's going to contribute a -2 because there's only one oxygen. So to get 0 overall, this has to be +2, because when I add up all the sums, I should get what I need to get for the compound itself. Now it's neutral. Now all of these are neutral, 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 neutral. So all of the elements need to add up to be 0 when I'm looking at oxidation numbers. So if nickel needs to be +2, and there is only one nickel, well, that nickel is +2. Over here, oxygen is -2 again, and there's only one of them, so -2. It needs to add up to be 0, so we know that this total must be +2, which means each cadmium must be +2. And lastly here, it's going to be 0. It's just simply a monatomic element. All right, so you should be able to run through questions 9 through 15. What I'll do is I'll get you to omit number 14 for now, though, but you should be able to do the rest. So 9 to 13 and 15, and then you'll be able to come back and do the rest. So I think what I'll do is I'll stop the video there, and then we'll come back and continue with the oxidation reduction reactions themselves.